Hi, fifth grade. Okay, so we are going to be doing our math review for Thursday, April 23rd. Okay, so let's check this out. Let's look at number one. 12 inches is in 1 foot, and I need to know how many inches tall would someone who's 5 feet 9 inches be. So what I want to do is I want to just look at my straight conversion because I know inches, I know they're going to be more than 9 inches. I need to know how many inches tall. So I'm going to take this 9 inches and I'm going to put it over here and I'm going to take it away from this conversion. So I know to go from 1 feet to 5 feet, that's times 5. So to go from 12 inches to 12 inches in 1 foot to how many inches in 5 feet, I would do to times 5, because what I do to one side of the equation, I do to the other. So 12 times 5 is 10 times 5 plus 5 times 2. I just broke up my 10. That's 50. That's 10. That's 60 inches. But I'm not quite done. I still have my 9 inches over here. So a person that is 5'9" is equivalent to 69 inches tall. Okay, moving on to number 2. Number 2, where my task was to add 1/6 and 1/8. So when I drew a model, I drew a hole and I cut it into 6 pieces, and then I colored in what represented 1/6. So I know I can't add these two fractions because they have different denominators. They're cut into different pieces. So what I did find out is that if I look at their multiples, 24 is my multiple that both of these numbers have in common. So if I cut 6 into 4 pieces, 1.5, and then cut those halves in halves, I now have 24ths. I still can't add 8ths though, because it's not transferred into a 24th yet. The nice thing is that with 1 as the numerator, I know that 1 is going to equal 3 24ths, because I would multiply the bottom by 3 and the top by 3. So now I color in 3 more 24ths, and my total is going to be 1, 2, 3, 4, 5, 6, 7 24ths. So this would be 3 24ths plus 4 24ths equals 7 24ths. My answer is 7 24ths. On to number 3. Number 3 is 3/4 times 8, and I can pop 8 over 1. So sometimes when we're finding a fraction of a whole number, it helps to draw this kind of tape diagram, and I sketched it out beforehand. So if I have 8, 8's my whole, right? And I cut that into 4 different pieces because I'm finding 3/4, right? Excuse me, I'm finding 3/4. So in each piece is equivalent to 2, right? If I count it out, 2, 4, 6, 8. So those all equal 8. But I want to know what 3 of those fourths are. So it is 1, 2, 3 of those fourths would be equal to 2, 4, 6. So 3/4 of 8 is equivalent to 6 whole, right? I'm multiplying a whole number by a fraction, so my product will be less than my whole number, because when we're multiplying a fraction by a whole number, our number gets smaller. Moving on to number 4. There's someone that walks 3.4 miles every day. How many miles would they walk in 5 days? So in 1 day, they're walking 3.4 miles. So my unknown is how many miles, and my known is 5 days. So if I'm going from 1 day to 5 days, I'm multiplying by 5. So to go from 3.4 miles to blank miles, I'm going to multiply 3.4 times 5. I'm just gonna algorithm it out. And I move 1 decimal in. So in 5 days, I would walk 17 miles. 17 is my answer. Moving on to number 5. Okay, for number 5, I needed to add 1/2 plus 2/4. I know that 4 is the denominator that they would have in common. And I could just add in my 2/4. Or I could just say, wait a minute, I know 2/4 is equivalent to 1/2. So when I add 1/2 and 1/2, I get 1 whole. Moving on to number 6. I needed to find the area of a rectangle with fractional side lengths. So my width is 5 4/5 of a foot. My length is 6 3/5 of a foot. And when I find area, I'm multiplying length times width. The trick about this is that I cannot multiply mixed numbers. I have to turn them into fractions greater than 1. So to do that, I multiply my denominator by the whole number, and then I add the numerator. So 6 times 5 is 30, plus 3, 33/5, times 5 times denominator times whole number, 5 times 5, 25, plus 4, 29. So I've got 29/5. I can multiply across the bottom, super simple. My next job as a mathematician is to multiply across the top, 33 times 29. So what I did, I tried to break down 29, because 29 seemed like an awkward number for me. So I did 10, 10, and 9. So 30, I love working with 10 because all I do is pop a 0 at the end of that. So that's 330, 330, and then 33 times 9, I could just subtract a group of 33 from here. So that would be, if I add 33, 12, 13, yep. So if I subtracted a group of 33 from 330, I would get 297, or I can just multiply it out using algorithm. So now I have to add 330 2 times, which I know is 660, plus 297, and that gives me 957. So 957 is my numerator. Now, I could just leave this and say 957 25 feet squared, but I'm going to push myself, and I'm going to make a mixed number out of this. So 957 divided by 25. If I think about a quarter can go into 95. Let's see, a quarter, I can have 50 cents, and I can have 75 cents, and then I have $1. So if I have 3 quarters, I have 75 cents. Bring that 7 down. Now if I have 4 quarters, I have $1 or 100. So if I have 8 quarters, I have $2 or 200. Anything, I can't really, that 7 is going to be off on its own, a little awkward. So I have 8. And I know 8 times 25 is 200 because 8 quarters is $2. And then I have 7 left over. Now, my 7 is going to continue to be divided by my divisor. So the answer for this is 38 and 7/25 feet squared. I don't think I gave you the unit in the problem, but so that would be my answer to finding area here. And when I look at this, 6 times 5 is 30. And then I've got these guys, so it's definitely going to be more than 30, and so I'm thinking that this would be the appropriate answer. Okay, moving on to the POD. All right, in my POD, I've got this guy, and he is putting tiles in his rectangular room. And he plans to put 3 rows of 63 tiles in each row. So I sketched that out. He has 3 rows, and there's 63 tiles in each row. But he does that for the 4 walls in that room. So this is just 1/4 of that continued pattern. So this will have 63, this will have 63, this will have 63, this will have 63, that will have. These are representing the 4 walls of his room, okay? So they first asked me, how many tiles? All right, so I know that I can do this a couple ways. I can do 63 times 3, and then I can multiply that product by 4. So I think that's how I'm gonna solve this. I'm gonna go 63 times 3. I'm gonna choose algorithm because I feel like it's gonna be really quick and efficient. 9, 6 times 3 is 18. So he has 189 in just this 1/4 of it. He has 1/4 of it. I need to find for 1 wall. I need to find for 4 walls. $189 plus 189 plus 189 plus 189. Well, that is 189 times 4. I'm going to algorithm this because, again, I feel like it's pretty straightforward with algorithm. 9 times 4 is 36. 8 times 4 is 32. 5. Right, 4 times 1. And my goal, so he needs 756 tiles. So that's how many tiles he needs. I have the answer for one part of this question. Now let me go to the next part of this question. Then they say tiles are sold in boxes, 14 in each box. How many boxes will he need? He's trying to get 756 tiles. So I'm gonna make a table. And when I set up the table, I wanna know, my goal is to get to 756. And we're gonna look at that really quickly. It's exponential growth. I talked about it in the other PODs. When we double, we can get to a big number like this pretty quickly. Let me show you what I mean. If I have 1 box, I have 14 tiles. So I need 756 tiles. If I have 2 boxes, I have 28 tiles. If I have 4 boxes, I have 56 tiles, because double, 28 doubled is 56. If I have 8 boxes, I'm doubling 4, I have 112 boxes. 56 doubled is 112. Still pretty far away, but my numbers are really growing quickly. If I have 16 boxes, then I have 224 tiles. If I have 32 and I'm doubling 16, then I double this for 48. Then I'm going to double 30. Then, let's see. If I double 32 and get to 64, if I double this, I know I'm going to go into the 800. So I know I'm going to miss my mark. So I'm going to add, let me try to add, let's go from 32 to 48. So if I have 48, that means I'm adding in 16. So I added 16 here. So whatever the 16 is equivalent to in my table, I can just add it up. So 448 plus 224 is 672. Okay, I'm inching up there. I'm getting closer. I'm getting closer. Now I'm going to add in 4 here. I think I'm just inching around it. I don't want to overpass it. So if I'm adding 4 here, all I have to do is add what the equivalent to 4 boxes would be, and 4 boxes holds 56 tiles. So 672 plus 56 is going to equal 728. See what I did? If I'm adding 4, I know that 4 boxes is equal to 56 tiles. Then I'm going to go to 54. And I'm just adding 2 more. And 2, because going from 52 to 54 is adding 2. And 2 boxes is equivalent to 28 tiles. So adding 728 plus 28 turns out to be 756, which ding, 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 ding. That's our goal. That was our target to get there in the first place. So the question is, how many boxes does he need to buy? And he needs to buy 54 boxes to get 756 tiles. Now, if this were the real world, I would tell this guy to buy 2 more boxes because I've done tiling before and tiles break and things happen. But this guy, things worked out perfectly. I'm not going to get in his business. Have a great